Hello everyone, welcome to the tutorial series of Python language quantitative trading practice. Let's pick up where we left off in the last lesson. How do we make the variable b in the example? We talked about in the last lesson not get reassigned to 0 each time, and then keep adding up to the final result we want. That is the number of all the positive lines in this K-line chart. How can we achieve such a function? This assignment operator that we talked about is going to achieve this function. This assignment, we have to expand on two keywords. One is called var and one is called varip. Let's start with var. How can we make our strategy achieve the function we want with certain modifications? We need to use the var keyword to restrict the declaration of a variable b. The var keyword has been used in our previous tutorials, but not stated in details. So here we'll explain the var and varip keywords in details. The official var description says that var is a keyword used for assigning and one-time initialization of variables, and the var variable assignment grammar, which usually does not include the keyword, would cause the value of the variable to be overwritten every time the data is updated. In contrast, when variables are assigned using the keyword var, they can keep state despite data updates. That's to say, the assignment of b to 0 is only performed for the first time, and then the strategy code will not perform the assignment of b to 0 when it runs on each K-line bar. Then we can run our strategy again with this modification, and we can see the value of b in the chart is different from the previous one. Here click backtest. Here we can see the value of b is different from the previous one. The previous value of b had been cycling between 0 and 1. After our update, the initial b is positive on the first K-line. Then b plus 1. The second K-line is still positive. b becomes 2 here. And it continues to accumulate. The value of b will be 3, 4, and so on. When the K-line is negative here, that is, when the closing price is less than the opening price, the value of b is not occurred. Here, the value of b is 4. The value of b is 4, and here it remains 4. And it remains 4, 4, 4, until until it encounters a positive k-line again. The value of b becomes 5 here. In this way, we can count the number of positive lines in the chart. Let's pull the chart to the far right here. We can see that there are 146 positive k-lines in this chart. With this modification, we can achieve this function. The keyword var allows the variable b to be assigned only for the first time, and then b will not be reset to 0 again each time the strategy logic is executed. Therefore, from the line drawing during runtime, it can be observed that the B is the number of positive line bars that have appeared from backtesting to the current k-line bar. Declaring the variable var can be written not only in the global scope, but also in the local code block. Let's write an example here. Strategy. Specify it drawing on the main chart here. And then we declare a variable a and assign it with the built-in variable close. Here we need to pay attention. Var keyword must be used to declare the variable a here. Then we declare a variable b and assign it to the value of 0.0. Then we declare variable c and assign it to 0.0. Declare a color to record the k-line bar value of the positive line using var for keyword declaration. Initialize it to 0 here. All of these variables above are initialized only for the first time, and the strategy is not reassigned to them when it is executed on each subsequent k-line bar. They will not be assigned again. Then we use an if statement to determine whether close is greater than open. If so, we execute the local block, declare the variable x with the var keyword, and initialize it to close. where the variable x is the variable declared in the local block. And again, only one assignment is made at the time of declaration. If it's executed again, no further assignment of x will be made. Let's modify the value of variable b. The colon and equal sign assignment, which we covered in the previous lesson, is used to modify a variable that has already been declared. The variable b has already been declared here. So here we modify it directly. When close more than open, assign x to b, and then modify green bar's count to make it accumulate. That is, when the closing price is greater than opening price, that is a positive line, then plus 1. We write another condition judgment. If it's more than and equal to 10. We declare the variable y in the local block and assign it to the built-in variable close. Then we modify the value of c and assign it to y here. Finally, we print out the above three variables, a, b, and c, by using the plot function. First, we print the variable a here. Name it a. And secondly, we print the variable b. Name it as b. Finally, we print the variable c. Name it as c. And we click backtest here. Oh, it reports an error. Line 26. Let's go back to the strategy code page. We can see that we lost the equal sign here on the three plot function, and we add equal sign to them all. Then we click backtest again. We can see on the chart it looks a little strange here. because the values span a large range. Since the beginning of the assignment of these are 0. For example, the line C is 0. So when it joins on one axis, the chart will show a relatively large difference. For easier observation, we can remove. Let's go back to the strategy code page. We can remove this line of code and let it draw on the subchart. At this point, click on backtest again here. We can see it draws out on the subchart. The K-line has not been compressed. Let's go back to the strategy code page. The variable A in the code holds the closing price of the first K-line bar in the data series actually, and the variable A has not been modified subsequently. We can see in the chart variable A has not been modified subsequently. We can see in the chart that the variable A always records the closing price of the first K-line. Because we use the var keyword in the code to qualify the variable A, it is only initialized once for the first K-line bar. If we remove var here, the variable A stays in sync with each K-line bar, that is, when we do not use the keyword var. The variable A is synchronized with each K-line bar if we use var here. The variable A is initialized only once, so the line A always records only the closing price of the first K-line in the chart. We look at variable B here. If it's a positive line, B is assigned to value X here. Here we need to pay attention to the fact that in a local code block, an X is declared, and then this X is used to assign a value to B. Then it is executed in this way on the first positive line. But what is the value of B on the second positive line? It is an updated X. Or is the value of X always the same? X is certainly always the same because we use the keyword var to declare X. It executes the initialization of X only when the close is greater than open. That is the first time to enter the code block. The subsequent value of X will not change because there is no modification of X in the code. So the value of X will not change after the initialization. It's always the closing price of the k-line bar when the conditional branch is entered for the first time. And then the closing price is also assigned and modified to variable b. So we can see in the output chart here. If the first k-line on the chart is negative, the initial value b of b is 0. If the chart starts with a positive line here, like this, b starts with the price of the positive line recorded. So we can see that the values of a and b on the chart are always the same. Because they are both fixed to the closing price of the first k-line. Since the first k-line is positive, b enters the if statement at the beginning. B and A are the same. Both of them record the closing price of the first positive k-line bar in the sequence. Let's move on to C. C is also initialized to 0. When C is modified, it is the value of y that assigned to C here. The value of local y is executed when the number of positive k-line bars is greater than 10. The next level of the local code block declares a variable y here and assign the closing price to y. Then y modifies the value of y and assign it to C. The assignment operator is used to modify an existing variable. That is, the variable C is modified with y. And this time, the value of C becomes the closing price of the 10th positive line in the chart data series. And let's go back to the chart. The 10th k-line bar of the 10th positive line is the closing price. The 10th positive line here. C equals to 33964.74, and the line of C is also the same value here. The blue line is always the same value, and it will not change from here until running to the far right of the chart. It won't change. When the local block is a conditional branch declaring a variable with var, we still initialize it only once if no subsequent assignment is made to it. It's only initialized once. What would happen if we declare a variable in a local block without the var or varip keyword? For example, we write y equals to close directly. Let's test with a test code here. We write a strategy test and let it draw on the main chart. Then declare a variable a, initialize the assignment to the built-in variable close. Then we declare variable b and assign it with the if condition. If bar index of the k-line is greater than 10. We will create a variable with the name a, assign it with the built-in variable open here. And then print out the variable a with the runtime log function. Here if I write in if a, print it in a different color, like 32 CD32. Oh, don't forget to quote it. To distinguish it, set the color code to distinguish it from other logs. Let the if condition return to a. Here, just write a. Draw the global a in the global scope with the plot function. Name it as a. And draw the variable b as well. Name it as b here. And print the contents of the variable with the runtime log function. Here, we output the global a. Again, we use another color to distinguish it. Here we use red. Then we click on Backtest. we can see that the chart was drawn out. The logs has been printed also here. Let's look at the front part of the chart first. The value of B is NA here. B starts to have a value only when their when it reaches here, B has a value. Because we restrict the condition that when the bar index is greater than 10, if bar index is greater than 10, only then will we assign a value to B. So when there is no value, B is null. When the bar index is equals to 11, B will have a value, and the value of B will be the value of the opening price of the current K-line bar, and the value of A printed globally, which is the value of the closing price. We can see that B and A are not the same. In the log message column here, the output of out if A, which is the global output of A, and the data value of A output in the if condition are not the same. The global output of A is the closing price. The global output of A is the closing price, and the output of A and the output of A in the if condition is the opening price. This example illustrates that if a variable declared locally, it will recreate a variable locally, rather than modifying some already declared variable. Besides the keyword var, we often use the keyword varip. Varip is a keyword for assigning and one-time initialization of variables. It is similar to the var keyword, but variables declared with varip return their values when the real-time K-line updates. Let's explain it through an example. We use strategy to set the drawing. Let it draw on the main chart. Declare a variable I with var. And initialize it to 0, which executes only once here. We use varip to declare a variable I and initialize it to 0. Then we use the plot chart function to draw a chart with changes in the values of I and II on the chart. With the first parameter set to true here, indicating that the chart is drawn on each k-line bar. Name it as II. Convert the variable II to a string with toString with the value of the parameter char. Specify the location of the chart above the k-line bar. And set the color as red. Okay, let's draw the second plot chart function. It's the same as the previous one. Set the first parameter as true. Name it as I here. And convert the variable I to a string with toString with the value of the parameter char. Set the location below the bar. And set the color green here. Then increment I and II for each round. And use the assignment operator here. We just learned to modify the assignment operator, that is, modify the existing variable I and let it plus increment by 1. And then the variable II is the same. Here we got a spoiler. The code will be different when it runs on the bar model and the tick model. And on our backtest page, we set it as bar model here first. Then we click backtest. We can see that on the historical kline bar, stage, each kline bar is incremented by 1. Until the end of the historical bar stage, each kline, which incremented by 1 every time. When the real-time bar is reached, we can see that these two values are different. And the red kline bar has increased a lot. Let's go back to the strategy code page. This is the difference between varip declared variables and var declared variables. They are not the same on the historical kline bar. They are both executed once per round, incremented by 1. When the historical kline bar ends, another real-time kline bar has to start. During running, varip declared variables and var declared variables undergo differently. Because on the bar model, the strategy code is executed once for each price change within a kline bar. The difference, however, is that each time II plus 1 makes a change, it executes to the next round without resetting II. However, although the variables declared with var are modified each time, when the next round is executed, I will be reset to the previous state. This is the rollback mechanism we have learned in model execution. The variable will roll back the value of the previous state before the kline bar is determined to go, and the value of the variable will be determined only when the kline bar is executed for the last time. The difference is that variables declared with var are subject to a rollback mechanism, but variables declared with varip have no rollback mechanism. It updates with every variable change directly without rollback until the current kline bar is finished. Let's go back to the chart. We can see that the green line increases by 1. Increases by 1 each time and then rolls back to the previous variable, which means that each kline bar is only plus 1. But the variable declared with varip has changed for each tick, and each change is already determined to take place without rollback, so it increases many times. But why did it increases? But why did it increases by 4 between 303 and 307? Because 4 ticks have passed in the middle. We use the simulation backtesting mechanism. It will simulate the number of tick prices generated in each K-line bar, which is equivalent to 4 simulated tick price changes in this K-line bar. So it has been incremented 4 times, from 303 to 307. The above is the performance of the strategy we talked about when the bar model is running. If we run this code on the tick model, the strategy logic is executed once after each K-line bar in tick model. So the historical K-line bar and the real-time K-line bar are exactly the same in the tick model state. So the variables declared by var and varip when it's set to the tick model are exactly the same. And we can try it, set it as tick model. Click backtest. We can see that they are the same. So the variable declared by var and varip when set to the tick model are exactly the same. On the chart, the status of the real-time K-line bar does not appear. Even in the real-time K-line bar stage, the value drawn by the red bar is still +1. Per K-line bar, this code behaves differently on bar model and the tick model. From the above tests, we can understand very clearly what effect the var and varip keywords have on the declaration of variables, and what are the roles for subsequent updates or assignments of variables. So that's all for today's lesson. If you find our video tutorial useful, don't forget to like, follow, and repost our videos. See you in the next lesson.